Hello, I'm Stefan Greber, project leader for LXD, and today I'd like to talk about LTS releases. LTS stands for long-term support and is one of the two kinds of releases we do for LXD. We do normal monthly feature releases, so those are the ones that do live stream about every month with the new features. And then every 2 years we do an LTS release that we will support for a period of 5 years. The first of those 2 years are pretty heavy on the backport, so we do both bug fixes and security, whereas the remaining 3 years are security only, and so see a lot less updates usually. This particular difference, the 2 years and 3 years, is because since we release an LTS every 2 years, we tend to be pretty aggressive on the bug fix backports so long as it's the current LTS, and as soon as it becomes the previous LTS, and we only focus on security on it. Now, the reason for doing the video right now is because we released LXD 502 just 5 days ago. And I wanted to take the opportunity to both go through what is in LXD 502, but also give some more details on exactly how our LTS process works and maybe explain what actually ends up being into those LTS releases. So if we look at LXD 502, we can see, obviously, this is the second point release for LXD 5.0. So LXD 5.0.0 was released around March, April-ish of 2022. LXD 501 was released just a few months afterwards with a bunch of bug fixes, and then 502 took quite a while longer. There is no fixed cadence. We tend to prefer releasing when we are pretty confident that things are solid, that all the backports are good, and that we're not going to see any kind of issues with the rollout to our users, rather than trying to meet a schedule and then get surprised and last-minute regressions and that kind of stuff. Now, for what's included in 502, you'll notice that even though LTS bug fix releases are supposed to be bug fixes and security updates only, there are a few things that you may not think actually qualify as bug fixes or security updates, and we'll go into a bit more details later as to how those got selected. As far as the actual changes, we can look at the detailed changelog here and see that we have a lot of changes that were backported. Like, I think from memory, we are looking at over 1,000 commits that were backported from the latest LXD release back to the 5.0 branch. And that's what was got included here in 502. There are also some larger features, larger changes that we can see here. So we did decide to backport cluster token expiry, remote token expiry. We backported a few small CLI changes to image filtering. We backported the support for overriding the device list during init and launch. We also backported support for restricting networks within projects and the CPU hot plug feature for virtual machines. So those could qualify as new features in some cases, but we can have our reasons for having done that, and I'll go into those in a tiny bit more details very soon. So that's what in LXD 502. One thing to mention with our LTS releases, like, first of all, as I said, there is no fixed cadence. We release them when we are ready, but we also tend to release them all together. So if we go look at the releases here, we'll see that within 24 hours, we released LXCFS, LXC, and LXD, all LTS point releases at the same time. The reason is that, LXD depends on the other two, and there's some more coupling that is kind of useful. We also like to just have to interact with packages once. Like, it's often the same packaging teams and different distros that does all three projects. So having things kind of scattered over time makes things a bit weird. You might also notice that LXCFS has a different version. It's got 503. That's because we released the bad version by accident. I believe it was LXCFS 501 that had some defect, and we had to release a 502 immediately afterwards. That was just fixing the build effectively. So it's off by 1 on that one. It's also no coincidence that LXD 510 was released a few days before LXD 502. We don't like it when we release a point release before a normal feature release, because that would mean that some bug fixes will hit LTS users before they hit monthly users. That's a bit of a problem, because if the bug fix contains a regression, we don't really want to see it first show up on production critical systems. So we tend to train and schedule things so that we do a normal LXD monthly release. We roll that out, we get early feedback. If there's any critical regression or anything, we pick it up then. That gives us an opportunity to still include those fixes into the LTS branch, and then we release the LTS. So that's exactly what we did. And we actually caught, I think, a couple of small regressions in 5.10 that we also backported the fixes for into 5.02, avoiding surprises at that stage. So kind of going back to LXD and the list of stuff included into it. So that's always a bit of an interesting thing to do as the person who's responsible for picking what goes into LTS branches. We normally don't want to include anything that is a new feature. There are obvious no-goes. It is completely impossible to backport anything that requires a database change or anything that will alter like anything on disk. If we do that, then we effectively break upgrade paths left and right and nothing works. So any feature that does any of that, we just cannot backport them. But there are some small things here that we do make exceptions for. And that's because we realize who our users are. LTS releases tend to be used by production users. Production environments tend to be very security conscious. And so we are sometimes interested in backporting features that have been done to improve overall security. That's why here you're seeing both the cluster token expiry and the remote token expiry being backported. Those 2 bits did not require any kind of database change or anything significant in the code base. Backporting them actually reduces the risk of further backports in those areas of the code base breaking in the future. So it's actually making maintenance easier for us. And it introduces effectively a security feature because now those tokens come with an expiry and it's less likely that someone can steal them and potentially get into an LXD system. There are some other ones that we backport just for the sake of easing maintenance. So that's one of those for the filtering in the CLI. Additional CLI bug fixes would have become difficult to untangle and cherry pick if that one hadn't been backported. And because it doesn't actually do any visible change in the user experience unless the user uses the new filtering bits, it wasn't really an issue, so we backported it. There are also some exceptions we make where we know that users have really been wanting to use a particular feature and that the lack of this in the LTS could actually push users that probably asked to be using the LTS onto non-LTS releases. And that's kind of the case with the next one, which is the ability to override a device list on init and launch. That's something that was actually a very, very small and easy change on our side, but that we got a lot of positive feedback for. And it was such an easy change to backport that we figured we should probably put it in the LTS so that we don't end up with LTS users switching to monthly just to make it easier to script instance creation and launch, especially to configure things like the root device size. It was a really easy thing, really safe backport, also because it had been in LXD releases for a few releases, and we know it works perfectly fine. It didn't change the API or anything, it was purely a CLI change, so it's something that we decided would make sense in order to keep more people on the LTS. The next one there is the restriction, ability to restrict the list of networks visible within a project. And that one kind of fits into the improving the security. It's kind of an between improving security in general in the LTS and also trying to retain people on the LTS. So with 5.0, we introduced support for LXD user, which is a small daemon that we run that allows the creation on demand of projects and restricting unprivileged users to those projects. It's great for multi-user systems with unprivileged users because they're still able to run containers and VMs in a safe way through a shared LXD. The issue we had with that implementation is that they are sharing network. So there's a single LXD BR0 bridge created on the entire system, and all of those instances can run on that bridge. And technically, it makes it possible to do things like MAC address spoofing, IP spoofing, and use that to either steal traffic of other instances on the system, or cause denial of service on other containers running on the system. That's not ideal. It's not a straight up security issue in most cases, because the concern that leads to the use of LXD user is to avoid a user escalating to root on the system. It's not necessarily for an issue for them to be able to interfere with other workloads from other unprivileged users on the same system. But still something that we prefer to fix. And so the support for restricting networks in projects makes it possible to create one bridge per user and then configure the individual projects to only see that one bridge, making that network issue completely go away. So that's why we backported that one. And then we've got another thing which might have puzzled some users in the past, which is why we're backporting so many virtual machine fixes in LTS. And the reason there is simply how we see VMs. In LXD, we see virtual machines as ideally an equivalent to container as far as the feature set. And we introduced virtual machines in, what was it, around LXD 4.0, with a pretty naive implementations. Didn't support a lot of features, did not have feature parity with containers by a long shot. And we've slowly been working ever since to make them get to feature parity with containers. And so we've usually been treating any of that work as being a regression fix, effectively. The advertised goal of VMs within LXD is that they are at feature parity with containers as far as all of the config keys and everything that you can use. So anything that does not work because it couldn't be implemented or just hasn't been yet, we've usually tried to backport into the LTS branch. One thing to mention there is that like all of those changes, because LXD already supports those features in general through containers, means that they are pretty small changes that are tied only to the VM implementation, only in our QEMU driver. They never come with database changes, they never come with API changes, they never come with anything complex as far as LXD is concerned. It's purely generating more config to map an existing config key to the right action within the virtual machine. So that's why we've been backporting a bunch of those. It's not always an easy call. It's definitely like I've got to go through every single commit that goes through LXD and then decide whether we see this to be a feature on its own that will not get backported at all, or okay, this looks pretty minor, and if we can backport this is going to make further maintenance significantly easier by not having to deal with code conflicts going on afterwards. Which is really the main risk with this kind of maintenance. Like when you're looking at hundreds of thousands of commits and you need to apply them all one by one, I'll show you in a tiny bit the tool we have to do this. It's possible for some of those changes to apply seemingly cleanly, but not like effectively the tool, in this case Git and patch, not having noticed that it's not an actual good fit, and the code will build and the thing might work, but with the wrong result. And so in many cases, we have to always balance like, okay, this change, can we maybe take it without the actual feature so that we have all of the code refactoring and the code reshuffling be identical in both the LTS and the current Git repo, so that additional backports that we do will apply cleanly and with a much higher chance of actually working than if we decide to reject a whole bunch of changes because we find that they are potentially too intrusive for a stable branch. So it's really a balancing act. I think we've done a pretty good job so far. LTS releases tend to be pretty solid, but it's definitely a balancing act. The other thing that's probably interesting to point out is that we've had requests in the past of like, oh, should I send like a pull request or a request for something to be backported or a fix to be sent to the stable branch? There's no point. We literally go through every single commit. And I can show you the tool we have for that. Unfortunately, the tool doesn't have a lot to show right now, but we can probably cheat and have it show more things. So we've got a tool called pending stable that I have. And what this does is it takes the master branch and compares it to the current branch I'm in, and then shows any commit that was not considered. And if I run it in interactive mode, which is what we do when we deal with large sets, what it does is it will show, again, the exact same commit. There we go. But now with the ability to apply it, skip it, mark it as a feature, mark it as irrelevant, mark it as differing between the two branches, and giving the ability to see the content. So in this case, we can see that the change is to just add a mention in the doc for LXC cluster info. The LXC cluster info command is not in the LTS branch. This was not backported. It's considered to be a feature. So in this case, this will not get backported. And it's not a feature on its own. It is just irrelevant. So I go with I, and that just then saves that state, pushes it into the branch we use for tracking of stable releases. And once that's done, then my backlog is going to look completely empty. So if we look, there we go. To give you maybe a better idea of what's going on, if I go back a whole bunch of commits, there we go, and I rerun, now it's going to show me a much larger set. Okay, so we can look commit by commit, and often if I run it soon after the things have landed inside of the main LXD repo, I actually remember enough to not have to look at the diffs, which is convenient. But a lot of those, we can figure just apply them. And that just applies those commits directly to the stable branch. I'm kind of hoping one of them will fail, but I don't think any of those two in that batch, I believe they all apply cleanly. Because if one of them was to fail, then I would need to go and manually resolve it. And after manually resolving it, when I rerun the tool, it will, yeah, okay, they all succeeded. When I rerun the tool, it would show me that commit again, even though it has been backported, because now its content is different. And that's what the differs option is used for, to effectively record this commit as, yeah, we've backported it, but it is not exactly the same. So just telling the tool to skip that in the future. And yeah, feature is used to just mark as one or a set of commit as this is clearly a new feature. We don't want to get any of this. And all of that state is actually recorded also in Git, but we've got a repo with a file on the side. And all it does is that it keeps track of every single one of the commits that didn't apply cleanly and records why. So that doc clustering we went through is showed here as being irrelevant. And we can see what are the most recent ones that needed alteration. So those three needed to have specific versions written for the stable branch directly. So more irrelevant ones, here is a new feature. So it was, again, cluster info, but it was when that branch was considered. So you can see that the test was marked as being part of a feature branch. Same thing here with the actual commits that introduced that stuff. They're all marked as being features. And yeah, that's effectively how we generate this. So it's completely automated as far as comparing the branches. We don't need to manually track this. We've got the tool that does it directly. And the exact same tool works for other branches. So if I go on LXCFS and I go look, make sure my master branch is up to date. Okay. And then we go into stable 5.0, make sure this is up to date too. And we run it there. Then we can see here that there was a change to the rendering of template in Ginger. This actually does apply in this case. We just apply it, and it's now backported, push that to the stable branch. And that's it. There's no more backlog on this one. Same deal with LXC, where we can also check if there's anything there. Stable 5.0, make sure it's up to date. The exact same thing, running it interactively. This one removes a broken script. Sure, apply that, no more thing to apply, push, and we're done. So that's what we do kind of in the background. We try to do it a few times a week to make sure that there's no backlog in any of the branches building up. Sometimes more or less successful. With a bunch of travel towards the end of the year last year is how we built an absolutely insane backlog for the LXD branch. LXD stable 5.0 had a backlog of 980 or so commits when I went through them early this year. So that took a while because the backlog was so long that some of the changes I just didn't remember anymore. And it took a little while to go through all of it. I think it took me 2 or 3 days to process that. But this is effectively how that works. And to check, we can check actually how many changes we had between LXD 501 and 502. 9, and let's see. Yeah, so we had just slightly over 1,000 commits between LXD 501 and LXD 502. So 1,063 is what we ended up dealing with there. And yeah, once the branch is all processed and we're ready for release, we actually just go change one file here, change the version number, and then do a release commit. So if we look at 502, that's what that looks like. There's a signed commit, signed tag that just changes the version. Push that, generate a tarball, and that's it for a new LTS release. All right. Well, I hope this was useful, both to give you an idea of what went into LXD 502 and why we chose those particular bits, and also give you a bit more of an overview as to how we make those LTS releases, and also the behind the scenes of the actual tooling and scripts that we use to make it all possible. I hope this was interesting. If you've got any questions around any of this, please leave them below or on the community forum. There are release announcements for LXD 502, LXC 502, and LXCFS 503, all on the forum as well. If you've got any issues, any regressions about on any of those, feel free to open a topic on the forum or on the correct GitHub repo for the different projects that you might be hitting issues with, and we'll look into those. So far, things look pretty stable, and the rollout, I think, for LXD 502 is almost reaching its end. We've been doing a pretty slow phased rollout, but since we're approaching the end of the week, it should be mostly done by now. So thanks for watching, and see you in the next video. Bye.